Welcome to STEM Professionals. In this video, we'll discuss the questions based on Chapter 1, and the level of questions would be from moderate to challenging. Now, the questions will be based on the following topics. The first one, dimensional analysis, and the next one is the unit conversion. So let's start with the video. So this is our first question, which is based on dimensional analysis, and we have to tell that which of the following equations are dimensionally consistent. Now there are four parts. I'm going to solve only two parts. The other two parts you can solve. So I'll be solving the B part and D part. A and C you can solve on your own. It's very easy questions. Okay. So the B part, which is V equals to 1 over 2 A times T square. Now what I'm going to do is I'll be writing the dimension of the left side of the equation and then the right, and then we'll compare that either the dimensions are equal or not. So for velocity, it is meter per second. So meter per second means length over time. This will be the dimension for velocity. Now the right side we have 1 over 2. Now 1 over 2, it's a dimensionless quantity. A is acceleration and its dimension is length over t square. And time, the dimension is t and it's squared. Now here we see that this one and this one will cancel, and the dimension for the right side we have L. Now if you compare, we can see that the left side of this equation have dimension L over T, and here this is L, which is not equal. Therefore we're going to write that this equation is not dimensionally consistent. So this is the answer for the B part. Now next we can solve the D part, where the equation is V square is equals to 2AX. So same procedure we're going to follow. First I'm going to write the dimension for V square. So V is velocity. So dimension for velocity is length over time and it's squared, is equals to 2. It doesn't have any dimension. Now acceleration we have length over time square, and the dimension for x here is distance. So dimension for distance we have L. So that would become L square over T square. This would be the dimension for the right side of this equation, and left side also this is L square over T square. So the dimension of the left side of this equation is equals to the right side. Therefore we can write that this equation is dimensionally consistent. So this is our next question, and it says light that plant absorbs to perform photosynthesis process have a wavelength nearby 675 nanometer. Now we have to express the distance in millimeter and in inches. Now this question is pretty simple, and we have solved multiple questions similar to this. So I'll be writing the unit conversion, and rest you have to do on your own. Now the first one, we have to convert this nanometer into millimeter. Now 1 nanometer, it means 10 to the power minus 9 meter, and 1 meter, it means 1000 millimeter. So this is the unit conversion. Rest you can solve on your own. Now for the B part, we have to convert it into inches. So 1 nanometer is same, that is 10 to the power minus 9 nanometer, this meter. This will remain same. Next 1 meter, it means 39.4 inch. So this would be the unit conversion for the B part. So this is our next question, and it says that 1 liter of pure gold weighs 42.5 pound. Now if you discovered 1 feet cube of the pure gold, how much would it weigh in pound? So we have to calculate the weight for the pure gold, whose volume we are given to be 1 feet cube. Now this is moderate type of question. So we'll be first converting this 1 feet cube into 1 liter, and then 1 liter, we are already given that 1 liter has weight 42.5 pounds. So 1 feet cube. Now 1 feet cube, the unit conversion would be 1 feet cube in liter, it have 28.3 liter, and 1 liter, it means 42.5 pound as per the question, as per the data given in the question. So this would be equals to 1200 pound, or we can write this to be equals to 1.2 times 10 to the power 3 pound. So this is the answer for this question. So this is our next question, and in this question we are given that the characteristic frequency is about 3300 shakes per minute, and we have to find the frequency in shakes per second. Now this question is a very simple question. We have solved multiple questions, something like that. So I'll be just writing the answer. You can do this question on your own. So this frequency will be in shakes per second, it will be 55 shakes per second. This is the answer. So this is our next question, and here we are given that the sweet corn plant grows at 4.1 centimeter in height per day. Now we have to find the speed of its growth in millimeter per second and feet per week. So there are two parts. We're going to solve the A part first. Now the speed that we are given in the question is 4.1 centimeter per day. So this is per day. Now we have to convert it into millimeter per second. So first let me write the unit. This is 4.1 centimeter per day. Now we know that in 1 centimeter we have 10 mm. So we have converted this centimeter into millimeter. Now day into second. So 1 day we have 24 hours, and in 1 hour we have 3600 seconds, this much of seconds. So we can see that this centimeter, this unit cancel, this day and day will cancel, this hour and hour will cancel, and we are left with mm per second. So that would be equals to, this is 4.1 multiplied with 10, this is 1, no need to write, divide by, this is 24 times 3600. So that would be equals to 4.7 times 10 to the power minus 4 mm per second. So this is the required answer for the A part. Now next we can solve the B part. Now in the B part we have to convert it into feet per week. So first let me write, this is 4.1 centimeter per day. Now first we can convert this centimeter into feet. So as 30.5 centimeter means 1 feet, so we can write this way. Now next we can convert day into week. So 7 day, it means 1 week. So we have converted the units. So this day and day will cancel, this centimeter and centimeter will cancel, and we are left with feet per week. So that would be equals to 0.94 feet per week. So in 1 week the plant grows 0.94 feet. So this is the answer for the B part. So this is the next question, which says that the car's acceleration is 14 meter per second squared. Now there are two parts. We're going to solve the A part first. In the A part they are asking that acceleration, is this acceleration greater than, less than, or equals to 14 feet per second squared? So this would be that the acceleration would be greater. This is for the A part. The acceleration would be greater than 14 feet per second square. The reason is that there are about 1 meter, it is about 3.2 281 feet. So if you multiply this number with this should be greater than this number. So it will be greater. Now next, in the B part, we have to determine the acceleration in feet per second square. This is a pretty simple question. We have done multiple questions same like this. So I'll be just writing the answer. You can do it on your own. This is 46 feet per second square. This would be the answer. So this is all with this video, and the next video would be the last video where we will discuss few more questions on chapter 1, and then we'll proceed to chapter 2. Thank you.